Here's the review for 11.1 to 11.3. This is page 1 from section 1.1. We're going to find the mean, median, and mode of our data set. We're not going to use the graphing calculator to use the stat button to determine this. We're going to write this out by hand. When we add up our values of each one of these, we get 114. And we have 10 terms, so we know that the average is 11.4. The median would be writing the numbers from smallest to largest. So we'd have 4, 6, and 7. We got two different 8s. We've got a 10, a 14, 15, 20, and 22. So to find the median, we cross those off a pair at a time, a small and a large, a small and a large. You have two last numbers, so you got to take the average of those two. So you take your 8 plus your 10, which is 18, divided by 2, so we get an answer of 9. The mode is the number that repeats the most. Look at our other data set. When we add our numbers together, we're going to get 450. We see that there's 9 numbers, so that gives us a mean of 50. So we could say that X bar equals 50. That's our average. The median, we have 44 and 44 and another 44. A 48 and a 48, a 52 and a 53, 57 and a 60. We're going to cross out the smallest and the largest, and we keep repeating each pair there until we come up with a number in the middle. So our median is 48. The mode is the number that repeats the most. 44 repeats the most. Looking at calculating our standard deviation, we would have to find an average to calculate our standard deviation. The average, when you add up the numbers, we get 219, and we divide that by 6. That gives us 36.5. We don't need the range necessarily to calculate the standard deviation, but it is part of this type of number. We have 65 minus 18, which we have a range of 47. That still doesn't tell us how the data is typically spread out. That just tells us how far the smallest to largest is. Are all the numbers really close to a particular side, or are they very well distributed? So we're going to calculate our standard deviation. So we take our first number, which is 47, and we subtract our average and square it. Take our second number, subtract the average, and square it. Take each of the values, and divide by the total number of terms that we have, and that would be 6. So that's going to give us, when we type it into our calculator, 1,721.5, and we're dividing that by 6. Which when we divide that by 6, we get 286.9, and that comes out to 16.9. All by itself, that doesn't mean a lot, but when we start to compare it to other data values, this number gives an explanation of how each individual data is separated from each other. Let's look at the next one. The range, the largest number is 70, the smallest number is 10, so our range is 60. Our standard deviation, we have to first work with an average. So our average, when you add up the numbers, you get 236. And you divide that by the total number. So our average is 33.7. So our standard deviation is going to be 70 minus 33.7, quantity squared, 27 minus 33.7, and each of the terms we divide that inside the square root still, we have our 7 terms. So our standard deviation is going to be 2,683.4 divided by 7, all inside the square root. That comes out to be 19.5. So next, we're going to find the mean, median, mode, and range, and standard deviation. We're going to use a graphing calculator, and we're going to figure out what these different numbers are. So if we're going to use our calculator, we will start with turning it on. We'll hit the Stat button. You'll go to Edit. We'll type in our 7 numbers, 35, 50, 60, 60, 75, 65, and 80. Go back to Stat, over to Calc, and we're doing number 1, which is 1 variable statistics. It lets you pick which list you want to be in. There's a chance that your screen doesn't have all 3 lines here. It just says 1 variable statistics at the top, and your cursor is blinking next to it. You have the opportunity to plug in what list you want at that location. If you don't type in anything, it's going to default and use list 1 automatically. So just be sure your information's in list 1, or be sure to tell it which list to look into. So we can look here and see that our average is 60.7. Scrolling down, you'll see that the median is 60. The mode is the number that repeats the most. That happens to be 60. The range is the largest number, which is 80, minus the smallest number, which is 35, which comes out to be 45. Going back up, our standard deviation is 13.99. we would do similar calculations for question number 13. And we would get a mean of 7.2, a median of 7, a mode of 8, a range of 12, which is 14 minus 2, and our standard deviation comes out to 3.5. The data set below gives a city's high temperature in Fahrenheit during a 15-day period. Identify the outlier. An outlier is a number that is extremely higher or extremely lower than most all the other data. And when you look here, we have numbers that are in the 30s, we have a number in the 40s, almost the 50s, the 30s, the 30s, the 30s, the 30s, the 30s. So if all of these are in the 30s, and this one here is practically in the 50s, that would be considered our outlier. Okay, describe the outlier's effect on the measure of central tendency and dispersion. The 49 would increase the mean. That would make your average go up. It would not affect the mode. Okay, that's another measure of central tendency is the mode. The median would not change, or it wouldn't change by much. It could change by one number, but it would not change by more than that. So in general, let's say it wouldn't change much. It could change by one value, all depending on what was happening right around that center number, but it's not going to change dramatically. The range is a value of the dispersion. So the range and standard deviation would have some change in it. On the second page of this review, this is practice 11.2, we're looking at a constant value of 5. We're going to take the original data, which is 25, 13, 19, 20, 19, 16, and 5, find the mean, median, and mode. The range is standard deviation. The mean is 18.1. The median is 19. The mode happens to be 19 also. The range of this data is 25 minus 13, so that shows us that that's 12. The calculator shows us that the standard deviation is 3.6. Now, when we have our constant of positive 5, that's going to move the average up by 5, so we get to 23.1. The median would go up by 5, so we get to 24. The mode would also go up by 5. So that's at 24. The range and the standard deviation would not change at all, because our new maximum would be 30, our new minimum would be 18, and that's still 12 apart from each other. Our standard deviation, if you want to recalculate it all, will come up to be the exact same values. So there's no need to recalculate. You can just add the numbers to the central tendency values, and you keep the dispersion values the same. This time our constant is a negative 26. Our original data shows us that we have a 57 as an average, a median of 58, and a mode of 59. The range of our values, we have 65, 52 is our smallest, so that gives us a range of 33, or 13, and our standard deviation is 3.8. When we have this constant of negative 26, that's going to take a considerable off of our mean, which gives us a mean of 31.7, a median of 32, and a new mode of 33. The range was not changed at all, and the standard deviation was not changed at all. Now on the comparison, when you have a constant value and you multiply it to all of your values, so we have an average of 21.7, 25, and a mode of 25. If our range is 20 and our standard deviation is 6.4, we're going to take our constant value and multiply by 2. That's going to change all of our values. So we're going to have twice as big. We'll have 43.4. The median is going to be 50. The mode is going to be 50. Our new range is 86.8, and 12.8 is a new standard deviation. Working on the last set of numbers, to calculate the mean using our values that are given, you'd use your calculator and come up with 57.5 with a median of 156 and a mode of also 156. Our range is 15 and our standard deviation is 0.5. If our constant value is 0.4, that's going to make all the values smaller, 40% of what they currently were. So we'll get 63. Our median will become 62.4. Our mode is also 62.4 because we're taking 0.4 times the same value there. Our range is also affected by this value. So our range is 6 and our standard deviation is 2.0. We have a group of data. We're going to find the following values for the test score. We're going to use a calculator to help us determine this. Our mean of this data is 91.9. The median is 92. That means that we had quite a few high scores, but a couple low ones to throw off the average, to make it smaller than what the middle number even is. The mode is 92. The range of the value is 16, and the standard deviation is 4.9. We're going to give extra credit to everyone in that. So the best score is going to increase by 10, and so is the smallest score. So our mean is going to increase to 101.9. The median to 102.5 and the mode to 102. The range is not going to change because all the values went up by the same amount and the standard deviation does not change at all. So adding a value to the mean, median, and mode changes it by that amount. It does not affect the range or the standard deviation.